Alright, for questions 10 and 11, we need to write equations that pass through this point. And it's asking for equations that pass through this point that we know are going to be parallel or perpendicular to another line. So for number 10, we're actually going to write the equation of a line that passes through the point 2, negative 15, and is parallel to the line y equals negative 1/3 x minus 24. So I'm going to have to write my equation that goes to that point. I don't know what the slope of that equation is to write my line, my equation for that line. So what I have to do is I then have to borrow the slope from the line that it is parallel to. So we know they're parallel, and we know from class that parallel lines have the same slope. So I'm going to borrow the slope of negative 1/3 from that line, and I'm going to use that slope for my equation that goes through 2, negative 15. Once I have that slope, I don't care about that other line. All I care about is writing my equation for the line that I want to get. So it asks me first to put it into point slope form. So what I'm going to do is I'm going to do the y minus y1. So y minus a negative 15 minus a negative 15 is going to make it plus 15. And it equals my slope, which is m, negative 1/3 times x minus x1. So x1 in this case is 2. That is my equation in point slope form. So now I want to get it for part B into slope-intercept form. I want to get it into y equals mx plus b form. And I know from class that means getting y all by itself. So the first thing I want to do is I want to take that slope-intercept form equation, and I am going to get rid of the distributive property because there's no distributive property in slope-intercept form, right? I know that negative 1/3 times x is negative 1/3x. And then negative 1/3 times negative 2 is going to be a positive. Negative times a negative is a positive. And I can't cross cancel before I multiply because 3 won't divide into 2 into this case. So I have to do negative 1 times negative 2, which gives me positive 2, over 3 times, well, what's underneath that 2 if there's nothing there? 3 times 1 is 3. So what I have is I have my equation with 15 and a whole bunch of 3's. So I have two choices here. I can simply get y by itself by subtracting 15 on each side, or let me get rid of my fractions by multiplying everything by the lowest common denominator. The only denominator I have is 3. So my LCD in this case is going to be 3. And if I multiply the right-hand side by 3, I multiply the left-hand side by 3. So I do distributive property for both sides. 3 times y is 3y. And then 3 times 15 is 45. So I jump over to the other side. 3 times negative 1/3. I know that I can cross cancel before I multiply. 3 will go into 3 one time. 1 times negative 1 is going to give me negative 1x. And then 3 times 2/3. Well, 3 again will cross cancel into 3, giving me 1 times 2, which is 2. Basically what happened was multiplying by 3 took out the 3 on both of these fractions, leaving me with just the tops. So now that I've got everything the way it is, I can subtract 45 from each side, and that's going to give me 3y equals negative 1x minus 43. Again, y is not by itself, so let me divide by 3. And I know that y equals negative 1/3x minus 43/3. Now it looks ugly, but I'm allowed to have fractions in slope-intercept form. So that is my answer for part B. So let's do part C now. And let's get it into standard form. So standard form means that I don't have any fractions, right? So let's go back to my equation before I had fractions. I had 3y equals negative x minus 43 before I divided everything by 3 to get the y by itself in the previous problem. So let me take that part of my equation where I didn't have any fractions, and now let's get it into ax plus by form. I'm going to add x to each side. That's going to leave me with x plus 3y equals negative 43. So I have my x and my y terms on the left-hand side and a number with no x or y on the right-hand side. And that is my equation in standard form. I know it was a little bit of work with the fractions, but you're going to definitely see fractions on the test. So I hope that really helped.